Today we're talking on-site drainage. We're at the Venkatesh Project. We're with Pat Dugan. This is an area that doesn't have any sidewalks, and it doesn't have any gutters, and it really doesn't have any site drain. And we know from the permit that we can't run a bunch of water into the street because it's going to come back into our house or into the neighbor's house. And while I'm also standing around a bunch of pipes that you've put all over this site, and those pipes all seem to dead end right into here. And you're standing on what I can see is a 20-foot long, 4-foot diameter giant pipe in the ground. Tell me what's going on here and why you had to do all this work here.
Yeah, so we actually just got done with our site inspection with our civil engineer. And what we're standing on here is the stormwater retention system. Like you said, it's 20 feet long, 4-foot diameter piping, which they perforate on the bottom. They backfill.
They punch a bunch of holes in it.
That's right.
Okay.
So they have to drill a bunch of holes all across the bottom sides, halfway up. This entire trench, this trench was about 9 feet deep.
9 feet?
Yeah,
wow.
9 feet deep. So big hole, backfilled with 3/4 crushed rock.
Okay. And then the crushed rock is to allow the water that comes out of the pipe to go bigger in span and to basically percolate into the ground? That's
right. So it'll help it disperse without any obstruction of that fine particulate matter in the native soil.
Okay.
So our site drainage specialist also, it didn't call for a drain fabric, but we added that as well just to keep future silt from infiltrating into that crushed rock.
So this fabric goes across the rock, up over the tank, and then across the rock again, so that everything on top of here we're basically not washing fines or small dirt particles into the rock, which would clog the rock.
That's right.
Kind of like a silt would do to a river.
Yeah, okay. So to just prevent future degradation of the system.
Okay.
And we have this white PVC lines here. These are all the tight lines that go all around the property, and they run, which will connect into a sump pump, which then pumps it into the back of this retention system.
Got it. So the sump pump is going to be actually lower because we have a big property. We have a lot of these lines. It's actually going to be lower than this tank. We want it to pump into the top of the tank. And then basically the water collects there, goes through the holes into the rock, and eventually will percolate or seep into the ground.
Yeah, so from here, what it also has a secondary sump where as this pushes in, once it gets to a certain level, if it gets that much retention of storm water, it'll then push it out to surface bubblers to the west side of the property.
Okay. So why is that? Why do we have to do this? Besides the fact that we don't have stormwater drains here, why can't we just let all the water percolate into the ground where it falls?
Just area flooding. You know, around the house, you're going to have standing water in certain portions of the house. So it's just really to make sure that you have a really good drainage plan.
Okay.
It's important.
So the water falling on the roof isn't going to soak into the roof. And so the civil engineers are basically worried that without having this retention, this ability to kind of accommodate huge flows of water, that we would just have standing water all around. And then we obviously have problems like overwatering trees or mosquitoes or just not being able to access the rest of your house.
That's right.
This seems like a pretty expensive system, right? Like this isn't something that an average homeowner can do. Like we had to have big excavators here, and this tank came in a big truck. I mean, this is heavy duty work, right?
Yes. Yeah. So on remodels, there's something that's sometimes required, you know, a velocity box at the end or just a little site rock basin.
Right.
But on these larger scale projects, it's definitely part of the scope of work to have that retention system and civil drawings for all.
So we can basically assume that like on all jobs when we have a lot of roof area and maybe a lot of driveways or patios that aren't going to be permeable, that we're really putting more of a burden on the adjacent soil. And if that adjacent soil isn't freely permeating, meaning the water just kind of flows right through it and into the groundwater, we have to have a stormwater system.
That's right.
Okay. And what about the kind of trees around here? Like I noticed that this is one spot of the whole yard that doesn't have any trees. Is this like, can we not put this near a tree?
Well, the good thing about the location of this is under the driveway.
Okay.
So it's a good place to put it without potential, someone in the future, even though there is a full plan set.
Right.
If someone were to start digging around
it.
unbeknownst to them and run into a system like this, that wouldn't be good.
Got it.
So
Okay.
it's a pretty good spot to be like where it is under the driveway without getting too close.
And
to it.
this was required by civil engineer. It was also required by the city?
That's right. So per building requirements, they actually want the civil of record to come out and inspect. The county doesn't actually have a drainage inspector.
Oh, so this is actually just has to be approved by the inspector or by the engineer who actually designed the system, made sure we followed the rules, and then he signs a letter and sends it to the city, and the city says, okay.
That's right.
Okay, so it's not really like the building itself in that we have inspectors that determine the building is safe. This is really the engineer takes full responsibility for this.
Yes.
Okay, great. Well, if you're interested in learning more about stormwater retention or about requirements for when you build a new house, hit subscribe as we show you how to build a better way.